Good morning. This is a video produced by Mr. Crampton explaining to you how to find the nth term of a number sequence. Sounds complicated, but is a very useful little trick to solve a lot of worded questions. When you are presented with a sequence of numbers and you're asked to work out what the next numbers might be, usually it's okay, it's pretty straightforward, but what happens if you're asked to find a number that's way down the sequence and you don't have 3 days to write out the entire sequence? So this is a little video to show you how. Oh, I've drawn on the screen by that was a practice. Hang on, let me rub that out. Bye green line. This is a practice to see if we can actually work that out. Okay, so that's what we're going to work on today, is how to find the nth term of a linear number sequence. Right, so let's start off by unpicking some of those words. First of all, when we talk about a number sequence, we're talking about a sequence of numbers, like you can see here in number 1, 7, 10, 13, 16, 19, that have a regular function. Something is happening in between each number that is the same each time. Okay, sure, you've already worked out that those numbers 7, 10, 13, 16 and 19 are going up in threes. Okay, not too difficult. Now, you could carry on that sequence, but what if I said to you, right, in that sequence, what would the 232nd number be? You wouldn't be able to, you're not going to sit there and write that whole sequence out. But there is a way that we can find out what that is by using algebra. So the first thing we have to establish is what this word means. Oh, that was a bit thick, wasn't it? Let's make that a bit thinner. How do I make that a bit thinner? A bit smaller? Oh, there's an advert. Adverts everywhere. Right. Oh, no, don't like that. Right, this word here. Terms. What does that actually mean? And this is sometimes what confuses people. And it's really simple. All that word actually means is what position are the numbers in the sequence. Like you lot, when you try and comment on the next day's work and try and be first. 7 is the first term. 10 is the second term. 13 is the third term. 4th, 5th, etc. And that's all that the word term means. First, second, third, fourth, fifth, etc. What position are the numbers in the sequence? Now, what's fascinating about this maths is that there is a pattern there is a relationship between the term is in red, okay? There is a relationship between the term, nice blue colour, and these numbers. Okay, so that's why it's really important that we understand what the word term actually means. Okay, first, second, third, fourth, fifth. Right, now that relationship is determined by the function that is happening between each number. Now in this case, obviously, there is adding 3 each time. That's pretty obvious. It's adding 3 each time. So what we do, we use that information to start writing our algebraic formula. So I'm just going to jump down to question 1b, write an expression in terms of n for the nth term of this sequence. If you are adding 3 each time, what we do is we multiply n, and remember that n refers to the term, its position in the sequence. So if we wanted to find the 8th term in that sequence, we would replace n with 8. So, recap, term, position. Find the function between each number. It's going up in 3. Now, whatever it's going up by, multiply the term by that. Now, as you can see, if we went to the first term is 7, Now obviously 3 times 1, remember n is the term, does not equal 7. So we have to do something else to get from 3 times 1 to 7. So what's 3 times 1? Okay, obvious. Then what do we have to do to get from 3 to 7? Right, we need to add 4. Okay, so there is our expression of how to find the nth term of that number sequence. Okay, so here, does it work with the others? Right, well let's have a look at the 5th term. I'm going to change colour just to make it a bit clearer. Oh, purple. Lots of colours on here. So the 5th term, 7, 10, 13, 16, 19. Right, well let's work that out. Let's replace the term n with the term. Now what term is 19? What position is it in the sequence? 1, 2, 3, 4, 5. It's the 5th number in the sequence. So we would write to check. This isn't the answer to question A, by the way. 3 times 5 add 1 equals. So what I'm hoping... Oh no, I made a mistake. Why did I... Oh, now it's all gone. Bear with me. Let's do that again. What was my expression? Oh yeah. 3, because it's going up 3 each time. N, which represents the position, the term, where the number is in the sequence. And then we didn't get to 3 there, did we? So we had to add something. What did we have to add? 3 times 1. 3, oh yeah, 4. Okay, excellent. Right. So that should be our algebraic expression. Oh, I hit the wrong button again. For finding the term in the sequence. And we were going to check with the 5th term, weren't we? So the 5th term is 19. So what we're saying is 3 times 5, add 4, got it right this time, should equal 19. Now remember, BIDMAS multiplication first. 15, 3 times 5 is 15, add the 4 equals 19. Excellent. So I think we found our expression. 3, because it's going up by 3 each time. N, representing the position of the number in the sequence. And then when we multiplied it by 3, we had to add another 4 to get the number in the sequence. So, back to the original. Question B is done. Find a green tick. Why do we always associate colours with things like that? Green. Why can't it be another colour? Anyway, I'm right there. I know I am. Trust me. So, finding the 10th term is quite simple. All we have to do is replace n with 10. So it'd be 3 times 10, add 4 equals, multiplication first is 34. Yeah? 3 times 10, do multiplication first because of BIDMAS. 30, add 4 is 34. So we can tell you that if you were to continue writing that sequence, you can now find out what number is in any position, in any term of that sequence. Okay? Now, I have just got 2 marks for that because I'm clever. I'm not really. I don't know how to work this machine. Where are we? Right, let's get rid of everything. Okay. So, what if I said to you, right, what's the 85th term in that sequence? Why did I say that? That was hard. What's the 85th term in that sequence? Now I've got to try and do 85 times 3 in my head. Right, 80 times 3 is 240, 3 times 5 is 15, so that's 255, add 4 is 259, so it'd be 259. So the 85th number in that sequence there, if I was to carry on going, the 85th number would be 259. Okay? That saves you having to write that sequence out with 85 numbers in. Very clever, really. Okay, let's move on to the next question. Oh, I've got 2 marks there as well. Okay, a number sequence has nth term, 6n plus 3. This is the other way around. Write down the first 4 terms of this sequence. Okay, so replace n with 1. So it'd be 6. The first one would be 6 times 1, add 3. And that is all it is. So 6 times 1 is 9. The whole thing is 9. 6 times 1 is 6. And then you add 3. My brain jumped ahead of myself. Would be 9 there. Yeah? So, it would help if I actually pushed the right buttons, wouldn't it? Let's try again. 9. Let's do it with the second term. See if we can do it on our heads this time. So, 6n plus 3. So 6 times 2 is 12 plus 3 is 15. And there's something else you might notice in a second. 6, let's try it with the third term. 6 times 3 is 21. Okay. Now, you can see now where the 6n comes from, can't you? Okay? Because the 6 is what the term is going up by each time. Sarah says that 1008 is a term in this sequence. Explain why she is wrong. Oh. Well, that's difficult, isn't it? Well, can we use some algebra to try and work that out? So what she's saying is that 6 times n plus 3 equals 1008. Well, can we solve? If we solve that equation, do you think we'll be able to find out whether it is or not? Okay, so if I was going to solve this equation, I'd subtract 3 from each side first to give me, I should have made that smaller, shouldn't I? 6n equals 1005. And now, is 1005 in the 6 times table? Because I've got to be able to divide that by 6 and it not be a decimal number to see if it works. 1005 divided by 6. How are we going to do that? Let's do a bit of division. 6's into 1 into 10, go 1, carry the 4. 6 is into 4, 6, 30, 36. 4 left over. Right, no, it's not going to go, is it? Because there's a remainder. So 36, 45, so it'd be 7 with a remainder of 3, so it'd be 5. So it's not a whole number. So it's not gonna, that isn't gonna work, okay? And that is the evidence as to why Sarah is wrong. Woo! Doodling. Right. Well, last example. Just as a quick recap, and then I'll stop talking. Last example. What should we have now? What colour? No, I want orange. Ooh, let's have that orange. Right. A sequence of numbers is shown below. 1, 5, 9, 13, 17. Step 1. Find an expression for the nth term. Step 1. Find what the numbers are increasing by each time. So here, the numbers are going up by 4. So, oh, I forgot to put the writing thing back on. Right, 4n. Nice. Hang on. Now I'm confused. Because if 1 is the first term, 5 is the second term. Let's do it with 5, just as an experiment. So what I'm saying is that 4 times 2, because 5 is the second term in the sequence, 4 times 2 is 10. Oh. No, it's not. It's not 10, is it? How can it be 10? What's wrong with my brain? Never mind, we all make mistakes. Sometimes we get things wrong. It's not 10, is it? 4 times 2 isn't 10. always check your mental arithmetic. Sometimes things just don't sound right, which happens to me a lot. So 4 times 2 is 8, but then it's 3, so maybe I'll... Oh, hang on. Maybe 4 times 3 is 12. Ah, yes. Subtract, of course. I could use subtraction, couldn't I? Subtract 3. Right, let's have a look, see if that works. Let's pick the 1, 2, 3, 4, 5. Let's pick the 5th term and see if it works with the 5th term. 4 times 5 is 20. Subtract 3 is 17. Yes! Tick. Found the nth term, the expression for the nth term. Excellent. Explain why 95 will not be a term in this sequence. Oh, hang on. Let's carry on this sequence here a little bit further. What would it be? It was 20, 20 is going before 21. If I said to you, what would be the 1000th term in this sequence? 1000th term. 4 times 1000 is 4000. Subtract 3 is 3997. So without having to write anything out, I've just told you what the 1000th term in that sequence is. Explain why 95 cannot be a term in this sequence. 4 and subtract 3 equals 95. Okay, well, let's get rid of the... We've got to add 3 to both sides this time. Last time we subtracted, we've got to add 3. So I'll get the rubber this time. So let's add 3 to balance this. So if we add 3, we've got to do the same to both sides. That will become 98. 4n. Is 98 in the 4 times 10? Well, I know 100 is. So 98 can't be. It's got to be 96, isn't it? Because 4 times 25 is 100. So 98 isn't. So that's why it's not in that sequence. 98 won't be in that sequence. It'll be 90... It'd be 100 subtract, it'd be 103, it'd be 99, and it will be 95. Anyway, so it's not, and we used algebra to work it out. Okay, so let's go right back and do a quick recap of this incredibly long video that I'm sure you're very bored of by now, but this is really, really useful thing. Let's go back just to remind you. How to find the nth term of a number sequence. We call it a linear number sequence. There are all sorts of ways. If the numbers go down, it's quite an interesting thing if the numbers go down. But well, that's for another video. So, pen. Okay, good. Get rid of my scribbles. Term means position of the number in the sequence. Find the increments. Times that by the term. Start with 1. 7 is the first term, so 3 times 1 equals 3. What do I have to do to get to 7? Add 4. Done. And that is how you do it. Okay, good luck. I might put some questions up to do with that. And enjoy finding the nth term of a linear number sequence.